All right, guys, good morning. Today we're going to start our unit on evolution. And as you can see on the screen, I've got three extinct animals up here, and I'd like you to take a look at them and tell me what you think they are ancestors of. You might be able to guess the first one and the second one, but the bottom one you won't, and even if I tell you, you probably won't believe me. So give it some thought. Okay, this first one here is the ancestor to an elephant. This is the ancestor to a horse. And this is an ancestor to a whale. Yes, you heard me right, a whale. So all of these little globe things here are video links, and I will actually put those up there in Google Classroom so you can check those out, because I know you don't believe me, and that's okay. Now, obviously, we weren't around. We can't ask our grandmother, hey, what was this related to? So what they have to use are different evidences, just as Darwin did, okay? And we'll get to those as we go on. All right. If I asked you this question about adaptations, says three friends were arguing about what would happen if a population of rabbits from a warm southern climate were moved to a cold northern climate, and here is what they said. Bernie thinks all the rabbits will adapt. Leo thinks most of them will adapt, and Phoebe says few or none of them will adapt. So this is not about optimism or pessimism or anything like that. The truth of the matter is Phoebe is correct, okay? Because their adaptations are only as good as their habitat. Few or none of the rabbits would adapt to the change. Okay, one more. Is it fitter? Natural selection is sometimes described as survival of the fittest. Four friends were arguing about what that means. Here's what they said. Dora thinks fit means bigger and stronger. Lance thinks fit means more apt to reproduce. Felix thinks fit means able to run faster. And Hal thinks fit means more intelligent. So what do you guys think? Well, all of these things, bigger and stronger, let's do that one, okay? Does that work for an elephant? Sure. Does it work for an ant? No. Ants have been around longer than elephants. Okay, let's skip down to Felix, being able to run faster. Is that an adaptation that's an advantage for some organisms? Sure, think about the cheetah, okay? But there are other things that have been around on Earth longer than cheetahs, a jellyfish, for example, which certainly doesn't have any speed. Okay, and then Hal thinks fit means more intelligent. The intelligent life forms didn't come on Earth until almost last, so that has nothing to do with it. Lance is actually correct. However you're able to survive and reproduce, that's what survival of the fittest means in terms of evolution. Okay, all right, so let's just do some fundamental concepts here. One of the common misconceptions is that people believe that evolution means you get more and more complex as things evolve, okay? Well, that's not true. There is a picture, and you'll see the picture later. There are fish and bats and things that live in a cave where it's dark 24/7, and they actually are losing their eyesight. Okay, that means they're not getting more complex, they're actually getting less complex. And the next one, evolution doesn't mean things are superior. I want you to think of an earthworm. Of course, we feel like we are superior to an earthworm, right? But if we had to live like they do, we wouldn't survive. If they had to live like we did, they wouldn't survive. Okay, so this has nothing to do with superiority. So like Lance said,
please stop by the office before you leave.
Sorry, guys. So I'm not going to start over for that. So like Lance said in the previous screen, it's not about being faster, stronger, whatever. It's about being able to survive and reproduce. Okay? So the man that started this whole thing was actually Charles Darwin. And I'm sure you guys, if you Google Charles Darwin's name, you'll get a range of things. Yes, he gets credit for the theory of evolution now, but back in the day, he was actually chastised for his work. Okay, so his dad was a doctor, his grandfather was a doctor, so of course they assumed little Charlie would be a doctor. He couldn't stand the sight of blood, so he knew being a doctor wasn't for him. He decided to become a ship naturalist. So his most important expedition, he joined the HMS Beagle, which that just means Her Majesty's ship. It sailed from England. Okay, in 1831, they went on a 5-year trek, and their most important stop was on the Galapagos Islands. Okay, he found 3 organisms there that made him stop and think the most. Those are an iguana, a finch, which is a bird, and then these giant tortoises. And I'll show you pictures of all of these on the next screen. And I'll tell you what was unique about each one. Okay? All right, so here's Darwin a few years before he died. Here are the Galapagos Islands, and just to give you a little bit of perspective, here's the equator right here. Okay? And they actually named an island after Darwin after he died. So these are the islands that they stopped on where he found his greatest discoveries. Okay? And I don't know if you can tell or know how to read maps and stuff or geography stuff pretty well, but these are volcanoes. Okay? A lot of them are extinct, but some of them are very active. And the cool thing about these islands is back in the 1800s, they were uninhabited. That means no people lived on these islands. So the animals were free to live without man's intervention. Of course, now you can see that there's actually airports and stuff on these islands. You could only get to them before with a boat. Okay, so these islands were very different. Up here, right near the equator, rainforest, lots of tropical foliage, you know, all that kind of stuff. When you get further down here to like Hispaniola Island, they actually had seasons similar to we do. Okay, so the vegetation and the plants and animals and all that stuff were very different from island to island, and they were isolated. All right, so here are the animals that he discovered. Let's do the finch first just because it's my least favorite. If you guys go into a pet store today and ask to see a finch, they'd be yellow or green. All the finches on these islands were black, and that should make sense to you because if there were volcanoes and then ash got on the ground, there was no vegetation, the ground was pretty much black. And the only thing that was different about each bird was its beak. And its beak is different because of what it eats, right? They're almost like different tools for different jobs, just like their beaks are. Okay, these guys here with really broad, wide beaks, they're good at opening seeds that are very difficult to open. Okay, these pointy ones like these probably are insect eaters. If they have one that had a really long beak, they might drink nectar out of flowers and stuff like that. Okay, so that was the unique trait that these guys had. This iguana over here, he's my favorite. He actually reminds me of the dinosaurs on Jurassic Park. But most iguanas that you see around here are green, right? Notice his color, again, because of the volcanoes and stuff. And there's nothing to eat on the ground, so they actually adapted to be able to dive into the ocean, scrape algae off rocks, and that's what they ate. He looks like he could eat whatever he wanted, fish included. They're vegetarians. They eat algae out of the oceans and stuff. So cool. Very big, like 40 to 60 pounds. Okay, very, very big iguanas. And then the tortoises here, he actually found tortoises that, depending on what island they were on, they would have different length necks. So if you notice, this tortoise here doesn't have very much vegetation on the ground. It's more bush level. So he has a longer neck, and that adaptation helps him get vegetation off of the trees. The ones that lived up here near the equator, they had a teeny tiny little short neck like the turtles we're used to seeing around here. And then there was a third tortoise that had like a medium length neck. And these tortoises were so large that Darwin could actually climb into the shell of a dead tortoise. So they were very, very big. Okay. All right. So I want to just stop here and make a difference between artificial and natural selection. So natural selection would take place on its own, okay? Artificial selection is when man is involved, okay? So an example of that is all of the dogs and stuff that we have on this planet today. When man chooses the traits, okay, and they decide, I want dog A to mate with dog B, you end up with all these different varieties. Okay, so here's the ancestral wolf, which is what all dogs think they originated from. Okay, and then now we've got all of these varieties. This is man's doing. Okay, just like all our varieties of cows and cats and any other kind of fancy breeds that they have. All right. Okay, so Darwin said that in order for evolution to take place, 4 things had to happen. The first one is overproduction of offspring. So basically too many babies, right? If I'm a mama bird and I lay 13 eggs in a nest, I'm going to have to provide for all 13 of those babies if they all hatch and make it, okay? And that's when struggle for existence comes along. So they're going to struggle for food, shelter, water, attention from the mama sometimes, okay? All those kind of things. And then the theory of survival of the fittest comes along. If you have some kind of adaptation that makes you stronger, then you will survive, okay? And you will reproduce, if that makes sense. I can't type today, okay? So fitness is just your ability to survive and reproduce, and adaptation is anything that you were born with. And then natural selection means if you have the needs, okay, you have the traits that help you survive, okay, and you can do so, then you're going to survive, you're going to be the one to find a mate, and you're going to be the one to reproduce. Okay, so what descent with modification means is you pass on desirable traits, okay, and they continue to change and adapt as they go on. All right, so let me just show you these real quick. Okay, overproduction of offspring, too many babies. See this mama pig here, she has a lot of piglets, and this one can't even find milk, okay? Now, they're not like humans. They're not going to be like, oh, honey, you've already had your turn. It's so-and-so's turn, okay? Think about it over time. If that one piglet continually does not get milk, he or she will be weaker than the rest, okay? Which means, A, she may not survive, or even if she does, she'll be the weaker one, and she will be the unlikeliest one to find a mate, and then that means her weak little traits would not be passed on, okay? All right, so there are different evidences that Darwin used. He used the fossil record, so those would be like bones and shells, okay? He also used distribution of species, like where things live, okay? And then these are my favorite here, homologous structures. That means it's a similar structure, but a different function, okay? And I'm going to show you those on the next screen. We're going to skip analogous right now. Vestigial is a structure that you used to have, so it is either shrinking, wow, or lost because you don't need it anymore, okay? And then he also looked at the developmental stages to see if things were similar, okay? So I'm going to try and run through those real quick because I can only do 15 minutes and I've got 2 minutes left. All right, so here's the fossil record. He actually, this is the front leg of a horse. So see how they used to have toes and now they have the hoof. He looked at different fossils. He looked at skulls, all those kind of things to compare. Okay. He also looked at where things live. If you remember how they used to conjecture that it was Pangea, it was one continent. So if something here is similar to something over here, that would make sense because they've been separated because of continental, or what is it called? A crust action or whatever. Okay. And then homologous structures are same structure, different function. So human, bird, porpoise, elephant, see how the bones are arranged similarly, even though we use them for different things. So the bird looks least like the human, porpoise, and elephant, and that makes sense because these three are animals and this one is not, okay? And then he also looked at vestigial structures. These are things that we don't need anymore. They're reduced or lost over time. There's a vestigial tail. This whale here has a vestigial pelvis and femur. And what that means is there was hip bones there and its relatives, but not anymore. And this cavefish here is, amphibian, has lost his eyes and his color. Okay? All right. Last one, super quickly, appendix. Ours is shrinking because our diet has changed. And let me do this one really quick. Embryos actually show us some similarities. So you can look at these here. And then at early stages of development, we look very similar. And then towards the end, we look quite different. Okay, so that's how Darwin could see that we were actually related and that we evolved from one another. Okay. All right, so I'm going to stop there before it cuts me off, and then we'll continue with this at a later time. Hope you guys have a great day. Email me if you need anything.